Good morning, everyone. Welcome everyone to the AI Technology Meetup. So in our meetup group, we are having every month this kind of knowledge sharing session. This session is focused on reinforcement learning. It's a subset area in the AI technology landscape. So AI technologies are getting really popular day by day. There's a lot of interest on different AI technologies. In this specific session, we are going to look at reinforcement learning. It's a technique within the AI landscape. It's a type of learning, and we look at what is the importance of this type of learning, as well as what are the use cases and how you can apply. What are the tools and technologies available to apply this technology with day-to-day use cases and practical applications. My name is Sutta Bandara from Blue Chip Training and Consulting. We are providing AI technology training as well as we are having this kind of knowledge sharing session, partnership with startups organization. If you're also looking to speak up at our next meetup session, you can contact us as well in terms of knowledge sharing. Okay, let's get started. If you have any questions, you can post in the chat box. If you have, can keep the mic muted during the session, and we'll be sharing the record of the meetup at the end of the meetup session as well. Overview of reinforcement learning. So this is a type of a learning that you don't need to have a large set of data. So if you look at machine learning, if you look at deep learning, where you need to have a very large scale of data. So you need to have millions and millions of data, and we also need to have data engineers. We need to also go through processes like data transformation. There are a lot of things we have to do in terms of optimizing the data. But in terms of reinforcement learning, there is no need for data transformation or data processing, because the technique is completely different to a standard type of machine learning and deep learning. The main difference is that we don't need to input past data. There's no requirement to work on the past data in terms of reinforcement learning. So it's a type of a machine learning technique based on behaviors and punishments, like punishing on the positive and negative feedback. So what you are giving is the building an environment, right? So let's start with a very basic example. So let's say like a real world, we want to train a dog catching a stick. So you have a certain environment that we have to give. We need to provide certain action. So each actions you have certain rewards. So rewards could be both positive or negative. Then we can observe the environment as well as the agent. So based on these key features, we can set up our reinforcement learning. So we don't need to have past data set in terms of setting up reinforcement learning. It's all learned based on the environment. So what you need to provide is this environment factor. So where it's going to apply in terms of robotics, in terms of simulation, in terms of like have seen self-driving car. So this kind of environment could be real environment. We can apply reinforcement learning. So we'll dig deeper into the session, and we'll look at how each of these areas could be relevant in terms of setting up, and also real world examples on that. But remember these keywords throughout the session. We have this environment, we have this agent, we have a technique called actions, reward, and observation. So we need all these things to get started with reinforcement learning. So it's a way of training a machine. So we can adapt this technique actually from games. So video games, we have like agents, like gaming agents, enemies like that. So games are actually the initial steps in shown into this reinforcement learning. Nowadays also we can use these simulated environments to training our the reinforcement learning agents. So as I mentioned, there are key techniques or key topics that you need to first identify if you want to get started with reinforcement learning. One is the agent. So agent or the learner. So the person or the object that's going to learn. And you need to have an environment. So what kind of environment that you are going to do the training on. and you need to have certain policy, that means rules. So you need to set up certain rules to take action. Then you can give a reward. It could be a positive or negative reward. So if you think according to the rule, this is a positive thing, you can give plus reward. If it is a negative thing, you can give minus. So based on that, it try to learn, it try to adapt into the environment. So the best way to develop a AI model is to do this technique. Why? Because we don't need to provide the past data. It's actually learning from its environment. It's like kid how to learn like to walk. So he or she try to learn from the environment. Like the kid try to make mistakes. From the mistake, it learns, and then based on the learning, it try to improve. So that's the same thing apply in reinforcement learning. We make the agent is trying to adapt to the environment, and then it's try to make mistake, could be a positive or negative. Based on that, it try to learn. So it try to adapt into the environment. So now the advanced AI models are like that. It need to adapt into dynamically into the environment. So if you look at self-driving car, so driving is a different scenario. So it's different from road condition to road condition, especially with other drivers, human drivers. So then it need to adapt dynamically according to that. But if you try to train that with the past data set, it's never going to work because data set is not enough. So that's why reinforcement learning, or RL for short, is a technique that we can adapt, do the adaptive learning method without any data. So one advantage is you don't need to have data. That's where you can apply. Another advantage is adaptively applicable or dynamically changing into environments. So if the environment is dynamically changing, reinforcement learning is one of the good techniques that you can apply into the AI environment. So there are a lot of use cases like factory automation, the building on certain factories, robotic automation, then it could be a self-driving car. So there are a lot of like recommendation algorithms that we can have, or we can have implement in a complex system that dynamically change according to certain parameters and conditions where reinforcement learning can apply. So you need to know how we can, what are the fundamentals of reinforcement learning, and also how you can adapt these capabilities on real world scenarios. So main key point within the reinforcement learning, like getting started, is this reinforcement learning algorithm. So this algorithm is the key technique that we need to apply in terms of setting up reinforcement learning. So we need to know how to set up the algorithm. So there are techniques, and there are certain algorithm methods are available, and through certain frameworks we can apply. So now everything is open source, and through Python frameworks we can apply. So you need to then know what are the tools and technologies available to apply these algorithms. So as I mentioned earlier, these are the key things within the reinforcement learning or RL framework. One is the agent. Then we have the environment, and we have observation, reward, and action. So I will go back to that diagram I showed earlier. So here you can see now clearly, we need to have an environment. So environment is the condition, the sandbox that we need to give this condition. What is the environment that we build this model on? Then the agent is the certain application or the algorithm that learning on. The agent have certain action. So it can have certain action. Based on the action, we can provide the rewards. So the reward could be positive or negative rewards. So based on positive and negative rewards, it's learned from its environment. And then there are observations. So it can record. So based on the number of iteration, we call as training. So number of training times, it can be improved, and the model can improve overall. So we have this a single agent in a very basic type of RL technique. But now in the advanced techniques, we have multi-agent dynamic scenarios, like multiple agents can train on another set of multiple agents in the multi-agent scenario. But that is more advanced topic. But we can start with one agent which training from its environment. So that's where we need to set up the environment. So environment could be mostly like a real world environment. It could be a factory setup. It could be a supply chain. It could be a certain environment setup, real world environment setup in the like self-driving car. So then we need to have kind of a simulated environment to map these scenarios. So that's why the tools that we are discussing also have a kind of a techniques to apply these environments, because environment need to showcase real world scenarios. Otherwise, there always be a mismatch. So first thing you need to know is what are the core concepts. So in terms of RL, we have the environment. We need to set up first. Then we need to have at least one agent. Then agent have certain action that is doing within the environment. In this case, dog environment is sending a stick. Then dog is trying to catch in the stick. Then if the dog catch the stick, we give a positive mark. If dog not able to catch the stick, we give the negative mark. Then similarly, we can have observation. That means we can record all these things and get the final result. So if the dog know the technique of applying the stick on maybe different angle, in a throwing different speed. So that is how you build a training model based on that. So likewise, you need to set up these things. Nowadays, we have the tools and technologies, so you don't need to build everything from scratch. There are now open source frameworks we have. So I will go through that later. So where we can easily apply this. So you don't need to build everything from scratch. We at the moment we have a lot of tools and technology to do this. So challenges of applying RL. So it comes with some trade-offs. So main thing is to limited on application. So remember, RL cannot apply for almost all scenarios, right? So there need to be a certain environment. There need to be a certain dynamic parameterized environment that RL can be applied. Because this is a subset within the AI. That doesn't mean that any AI technique that we can apply in RL. So you cannot apply almost everything. Let's say we want to predict what is the tomorrow's weather. That's a regression problem. So you cannot apply RL there. So likewise, there are limitations. You need to always know in which areas that RL works fine. Based on that, we can apply. But if you apply for the correct scenario, if you apply for correct situation, then you can get a really good result by using RL technique or the reinforcement learning technique. So like if you are having a robotic or the robotic arm in the factory or supply chain, you want to train a complex real world environment where we can apply RL. So we can have that kind of a learning based on the environment. We can do the apply reinforcement learning on the real world environment setup. Sequential decision making. RL often involves sequential decision over time, where each decision affects future state and reward. So it's decision making within the RL is sequential. So where each of the action is matter for the next action. So let's say our agent, we need to that can take 3 actions, type of decision. So the decision 1, decision 2, decision 3. So decision 1 will affect the decision 2. Decision 2 will affect the decision 3. So based on that, it's a sequential decision. It cannot take parallel decision at the moment. In a single agent can have like step by step sequential decisions can take at the moment. MDP or Markov decision process is one type of technique that we can apply within the RL model. It's one of the most popular technique within the reinforcement learning algorithm, Markov property. So it's one of the technique that we can apply within the decision process. So these things now we can set up as certain parameters, certain configuration of like hyperparameters. We can set up these configurations within when you are setting up your RL algorithm. When you are setting up your use case, you can set up these things. Here you can see where the reinforcement learning sits on. As I mentioned, you cannot apply reinforcement learning for solve almost all the problem. So there are certain areas you can see certain areas in the deep learning that we can apply reinforcement learning, but not all the things in supervised learning or unsupervised learning that can be applied to RL. But certain things within the deep learning landscape that we can apply for reinforcement learning. And there's another subset within the reinforcement learning and deep learning. We call it as deep reinforcement learning, DRL. So that's deep learning with reinforcement learning also we can tie together to get more advanced kind of a model. But in this one, we look at only reinforcement learning, where how you can get started and what are the avenues that we can expand by using the reinforcement learning or RL technique. Right. So the supervised learning is, is all about label data. As I mentioned, we don't need to have any previous data in terms of setting up RL. So there's no requirement of label data. In most of the machine learning, deep learning project, our most of time will spend on labeling data, especially like data transformation, setting up a data pipeline, data cleaning. So 60% of the time we'll spend on that. So the RL is completely void that. There are no need for previous data sets. We don't need to apply any of the previous data techniques in terms of applying RL. So it's completely, we have advantage on that. So let's say you're trying to apply this problem into your organization, but organization doesn't have any past data. So then we can apply this directly. Why? Because it doesn't require any past data to get started. Because a lot of AI projects we have seen stuck because of the lack of data. Because we need to have proper data set in terms of working on machine learning or deep learning. But RL is not like that. We don't need any past data to get started. What you need is environment, agent, and other things like action, reward, policies, those things. Then unsupervised learning also we don't need. So that's also supervised and unsupervised is the main two techniques that we can have with the standard machine learning, deep learning techniques. But we don't need to go in that in terms of RL. I have shown the diagram earlier. I'll go back to that one again. So here you can see we don't need supervised, unsupervised. It's a completely different set, but there's a aspect that can connect with deep learning. We call this as DRL or deep reinforcement learning. That's how you can connect both deep learning and reinforcement learning together. But we look at reinforcement learning only. So the deep RL, you can see in this slide, it's another technique that's used reinforcement learning with deep learning. We call as deep RL. It's much more advanced than using RL because you are using deep learning with reinforcement learning. We call as deep RL, DRL, which is a much more advanced technique. So your model is more optimized. You can solve more complex problem than RL to use DRL. So in this session, we are not going in depth of DRL. We only look at RL, which is reinforcement learning, the core concept, what are the tools and technologies, and how to get started with the reinforcement learning. So in terms of the tool, one main tool is this Unity environment. So Unity is if you are not coming from this graphical environment background, Unity is a game engine, mostly providing 2D, 3D kind of a gaming environment. Is mostly supporting with things like the mobile games and 3D games. So then why you think how RL can be connected to Unity? Because I mentioned the main requirement within the RL is creating an environment. So Unity is by default is a gaming tool which is providing a 3D environment. So let's say we want to simulate a robotic arm. We want to simulate or we need to train on a robotic arm or factory automation. So then we have to simulate this real world scenario, right? So let's say something like this. So here we have training a logistic robot. So then our agent would be a robotic arm. So agent would be robotic arm. Then environment about how you can set up a robot to identify the object and place that in the correct position. Then we have a action reward observation from that. So then this is a good application of RL. So then this environment can be set up initially from Unity kind of environment. So Unity is just one option. Then we have the OpenAI Gym platform. Now is changed to Gym Market Gym organization. I'll explain that later. This one, the Unity, we can set up this kind of environment, and then we can train our agent to move, let's say in this case, this object into the correct location, right? So then once you finalize the model, then we can have the model data running in the actual robotic arm. So then that arm is now based on the environment how to adapt, because it's running through reinforcement learning. Otherwise, it's just logic. So some of the robotic arms is just logics like if do this, do that, something like that, just pure logic. But here what we are having is based on the environment, try to adapt. So it's adapting into the environment condition because it's trained on that. So that's where the application side comes in the RL. So the tool in terms of developing this, in terms of creating this, we can first use the Unity RL, which is Unity ML agent. So Unity ML agent is kind of a technology that we can use to build this. You can go to this URL and see Unity ML agent. So I will share in the chat as well. This is the first tool that we are looking at, Unity ML agent. Which is a kind of a technique that we can apply to look at this problem. Because Unity is really good with solving 3D environments. So really good with building or showcasing, like setting up a 3D environment. So because of that, we can use the Unity 3D environment to simulate our things. Yeah, it's depend on how you setting up the environment, right? So you can create like different environment conditions. So we call this as a policy. The policy is a set of rules and regulations, right? uh, Policy set of rules and regulation. The question is how you can set up a reward for like a certain objects. Where things like, let's say we can have like multiple agents, or we can have more than one agent set up. It depends on what is your requirement would be, what kind of a solution you are looking at, right? So it's not always moving an object, right? It could be based on the certain parameters changing some action. Like let's say, for example, we can apply RL for recommendation. So recommendation means personalized recommendation. Now you have seen that in like advanced version of YouTube or advanced version of TikTok, where you get personalized recommendation, or advanced version of e-commerce. So you get a personalized way of recommending. So the algorithm knows how to like adapt into the changes of the user. So if you select one or two objects, then it try to dynamically adapt and give that. So the personalized recommendation is the next wave of recommendation, where the recommending product is completely personalized to you. So that's a RL application, right? Reinforcement learning, we can do that. So it's not a movable, or it's not like a moving thing. So it's setting of parameters. So based on the changes, so it's not always need to be like moving things, right? So it could be based on the behavior. So actionable behavior. So let's say we have e-commerce site, we have product catalog. So based on the user click, user identification, based on the user's changes, we can give a dynamic way of doing the recommendation. So a lot of the big sites doing at the moment, like YouTube, TikTok are doing that. So because of that, social media start doing that, Instagram. So where we are engaging into the platform much more heavily because of that. So we get a personalized experience. Every time we go into this platform, we get a personalized experience. So that's a advanced version of recommendation. Basic recommendation, of course, we can do this using machine learning techniques. But advanced recommendation, which is going as a personalized recommendation, is personalized for your behavior. So that's we can apply through ML agent. So RL agent. So that is not do that. So then we can train based on certain condition, based on certain parameters, give the reward. So it could be positive, it could be negative based on certain actionable items. So we create this policy, there are no rules. So based on these rules, we can set up that. So if you apply RL for, let's say, e-commerce site, then we have to set up according to that. So it's not always doing the movable things like go there, like move 2 points or something like that. Is what kind of actions that you can take. So we can use the rewards by providing the recommendations. So that's a kind of a technique that we can apply. So all we need to set up in the policy how to choose properly from a certain goal. So that's apply on these things. So I will explain more in the use cases as well, how you can set up the reward. So one scenario is like I mentioned, we can apply the for e-commerce. So then you don't need to move the items or move the agent according to that. So those are more dynamically parameterized based on the user actions, right? So I think that's answer the question that asked in the chat. So this is the link for getting the Unity ML agent. So this is one option. Of course, we have done one option as well. So in this one, you have they have also created a sample environments as well in terms of certain gaming environments or certain adaptive environments. I will demo them as well in a few minutes time. But here you can see they are providing this ML kit. Remember, Unity ML Agent Toolkit you have to download. It's not like creating a game. What you are creating is this kind of a environment, and then it's try to adapt. It's try to agent try to learn from that. Of course, we cannot use this in like the earlier use case I mentioned, based on the question like e-commerce site. We cannot use that. But if you have a certain real world like a movable environment, you can apply that. A movable environment is all based on the parameters conditions that you put within the environment. But these are movable environments like real world environments. Then we can apply Unity ML agent, and then agent is training according to the movable conditions, right? So then we can, nowadays we have a lot of cloud environment and cloud tool. So we can use like Hugging Face platform even to test it out this environment, right? So I will show it. So if you go to Hugging Face spaces, and if you search for Unity, you can see there are a lot of agents are there. So Hugging Face spaces is a kind of a ML hosting environment. They are giving Hugging Face is a really popular also platform at the moment in terms of influencing AI models. The Hugging Face spaces providing kind of hosting environment, so where we can see running hosting projects, hosting environments within this spaces. So if you go to Hugging Face spaces and search for Unity, there are like a couple of projects you can see they are listing. These are from other users that who have hosted these projects. So this is running that hosted project. This is actually running a real live application. Just for the time being, I will show that running application. You can also go to this link. This is a live link, public link, and you will get something like that with Unity, and you can select a model to choose from. So here we can select which model that we can choose from. Then purple team and blue team, and then we can have these two teams training with each other to perform best, right? So how these two are related. So here it apply with the soccer rules. So the policy would be soccer game. Rewards will be like soccer based rewards, and then just try to learn on that thing onto playing these elements of the playing this element to adapting into the environment. So that is where this is really beneficial and useful. How is try to learn from this environment. So you can see both the blue team and purple team. So initially, the main thing is I want to highlight the training time is much longer than the machine learning and deep learning, because in machine learning and deep learning, especially in machine learning, training time is really small because we have already a data set, right? is mostly clean data set. So then we already have input parameters to get started with. So let's say a machine learning project is taking 1 hour. Deep learning project could take 2 hours. Then reinforcement learning project could take 5 hours. Why? Because when we give all these setting scenarios initially, it doesn't have any parameters to get started with. Start from zero. Is try to learn from zero. It's like we learning something completely new. So we start learning something new today. So then we don't know anything about that previously. So that is how RL starting to learn. So the learning time will takes more time. But the advantage of learning for yourself, if you learn by yourself, you learn a lot. That's self-learning. So something like that. In reinforcement learning also, the model is much more stronger. Why? Because it try to adapt to all the possible scenarios. But in machine learning, we are giving back the past data. So it's always try to create the model based on the past data only. It doesn't know anything outside the past data. But here, try to get almost all the possible combinations. Because try to make a lot of mistakes. You can see first 1 to 2 minutes, ball doesn't move at all because the objects, the agents trying to figure it out, getting how to get closer to the ball. Then only it's try to go into closer to the ball and trying to hit. So you can see this running real time. It's in the running mode. It's running real time, and this is in a public URL. You can also go to this URL and check this. So it's try to adapt how to stay within the environment and also how to kick. So in this case, it's a football agent. So it's try to how to kick a certain ball. So it's try to learn from its environment, but it take more time. Why? Because there's no enough data at the beginning. There's zero data at the very beginning. So it's try to learn from and adapt from that initial starting point. So that's why it takes more time to do the training. So we can use a certain cloud platform. So we can use in this case using Hugging Face spaces. So likewise, whatever the training environment you can use, because it takes a lot of time to do this training on. So once you have a proper training completed, then you get a model that can have the adaptivity into multiple scenarios, because in traditional machine learning, it doesn't have that capabilities. Always try to fix within the given data set. But here is try to generate new scenarios. It's try to learn or create new conditions, and based on that, it try to learn. So the next learning is based on the previous learning, right? So that's why it's a kind of adaptive learning. It's try to increase the learning on its own. So that's why the RL agents are super powerful compared to a machine learning or deep learning model. Because try to learn on its own based on the environment, reward, and actions. And we have now deep RL, which is even more advanced, as well as multi-agent scenario. So the multiple agents can now interact in advanced scenarios. So in here, we have only 2 agents interacting, but it could be hundreds of agents. We can have a interaction. So that's more advanced scenario. So the agent can talk to each other in different environments into different scenarios. That's again kind of advanced scenarios into that. But the very basic way, we can have one agent within the environment and can be adapting and training within the environment. So I have shared this link as well. This is running in cloud. So now a lot of those we can test it easily in cloud, and we can see how it's going to adapt. So here you can see some other things as well. So all these are Unity ML agent work. So you can see the status. So some are running and some maybe have some bugs. So we can check and see which one is working correctly. So and also you can create your project, and you can host your project also into the spaces and test it out. So it's a quite easy way to test out your environment and get an effective way of identifying the problem. So this is a Worker agent. Let's try this one as well. So this one trying to work like a simulation into that is try to adapt from that. So likewise, there are many examples. We are not doing a lot of detail in that, but only two examples we will go through for now. So here, in this one, you can see the Unity ML agent for working. So there are certain worker models, and then we can set up and we can run the agent. So here, we can set up the model, and then we can watch the agent play. So try to stand up and try to work on its own by on this agent. So here you can see how this can be applied through this. To try to work on its own and try to go into the goal, right? Just try to adapt into getting into the goal within the certain boundaries and the environment. So this is because Unity is good with 3D environment. So if you're building your RL model within the 3D environment space, you can use this technique, and you can just try to go into that cube and try to work into that cube based on the learnings, right? So try to adapt into that scenario, trying to learn from that given condition. And remember, Unity is not the only kind of environment. There's another tool set. I will explain next what is the other tool set that is available. But Unity, you can see have a clear visibility. We can apply to Python Unity ML agent and get the result like this when you apply it. So this is another one, Hugging Face Unity. You can note down the URL. This is also similar to the two examples I just mentioned. It's another one. So key concept, as I mentioned, agent is one of the key concept entity of the system that is responsible for making the decision of the environment. It could be an entity, it could be a system. The environment is the external system that agent interact on. The environment receives the agent action. So based on that, it provides the feedback. Then we have states. So the current state, what are the state within the agent, right? And the action. So it would be, we can use certain rewards based on the action, like could be positive or negative. So the policy is the rules. So what are the rules or the boundaries that we define within the environment? And the reward is a factor, like as I mentioned throughout the session, that we give as a positive or negative indication. So these are the application. As I mentioned, gaming, you can see there's a huge usage for gaming. Resource management. So if you have dynamically, if you want to manage resources within a server space, within the certain repository, you have to do that. So that is another scenario. Personalized recommendation, as I mentioned earlier, because standard recommendation, we can use recommendation algorithms, which is mostly discussed in machine learning. But the personalized recommendation, where we can apply the reinforcement learning, where I dynamically adapt based on the scenario, based on the recommendation scenario. And the robotics is a clear application. So the game plane, you can see the notable one would be AlphaGo, which is defeated human. Like also it used in the Dota 2, StarCraft kind of games as well. The robotic side can be adapted to do the task, a lot of dynamic tasks, automation tasks we can do in the robotic space. As I shown earlier, we can train the agent to learn on this environment, and we can train a robotic arm according to this. The recommendation system we can apply through personalized content, a product recommendation. It could apply for e-commerce. If you have a certain video catalog, audio catalog, if you want to recommend certain item within that product line, we can do that. So standard recommendation, as I mentioned, we can apply through machine learning process, but this is more dynamically personalized. So nowadays you get a recommendation in the personalized. So the news or the tweets or whatever you get in a much more personalized way. So that's we can apply RL techniques. A supply chain management for inventory, demand forecasting, logistics in terms of minimizing the cost and maximizing the efficiency. We can use the RL. A control system. So if you have autonomous system, drone, industrial process, smart building, dynamically set up the conditions in the systems, we can use the RL techniques. It can apply changing, adapt change according to dynamic scenarios, according to the environment, it can adapt on the control system. So these are some of the use cases from the industry leaders. So this is from CEO of Epic Games. They have used reinforcement learning in their AI system in games, especially to enhance game mechanics. So you can see these things are already in use. This is not a future technology. This is already used, already applied, and now we are have to use more advanced versions than this because the core technology is already applied in a lot of use cases, and you can see from these examples. So it's used in Epic Games in their game developments. Then OpenAI 5 is a multiplayer online battle game, Dota 2 at high level, and also for AlphaMind, DeepMind. They use the RL technique to train AlphaGo game. Then Project Mambo, that is developed by Microsoft, the RL agents. Healthcare, this is from University of California, from associate professor. They have used to learn from large-scale healthcare data to enhance disease prediction and early intervention. So here you can use the AI system to dynamically identify the disease prevention and early intervention because the RL have this capability of dynamically adapting to a scenario, let's say a certain DNA or certain drug mechanism, drug calculation, identifying certain these parameters, dynamic nature of the parameter. RL have this capability to do that. So that's where RL can apply into these different areas. So in this case, a large-scale healthcare data to enhance disease prediction and the early intervention. Here, Massachusetts General Hospital used to personalize dosing of blood thinning medication, right? So that's dynamically setting up this medication to do the patient data, the recommended individualized dose. Then clinical decision support system to assess oncology to cancer treatment. So RL can provide the unique, because I mentioned earlier, it can apply for personalized recommendations. So likewise, it can dynamically apply for individual user. So in this case, IBM Watson RL technique, they have tested that, used it in the oncology department to identify the cancer treatment that is specialized to individual user. So how you can care or how you can do the drug treatments, individual nature within the use cases. So these are all applied at the moment on the different organizations or the different use cases. In the retail side, this is from IBM Watson Customer Engagement. They are used to get the deep understanding of the customer preference, optimizing pricing and promotion. So the recommendation goes way beyond. Let's say a person is probably going to buy the product. We can optimize the pricing, right? Within the certain boundaries, we can optimize the pricing. So then the person definitely going to buy the product, because if you optimize the pricing based on the user's dynamic preference, there's high chance of person going to buy the product because that pricing only visible for that user, and especially pricing and the promotion. So they have tested that, and these are all that applied at the moment, and those are all using at the moment. So then Tesco, a multinational retailer, tested with RL for customer preference and sales data to identify and improve the provide the right product for the right store to improve the customer satisfaction. Then grocery store chain, they tried the RL for the customer foot traffic to increase the foot traffic again based on the optimal arrangement of the product. So how to plan the optimal arrangement to increase the footprint, not putting the same arrangement in all the same stores. So let's say based on the different states or different cities, changing the arrangement. So how you can increase the foot traffic from that. The supply chain, this is from Chief Data Scientist of UPS. Reinforcement learning empower the supply chain for transform operation to get the insight for the optimized inventory and improve responsive and deliver exponential customer experiences. So how they can optimize the inventory, and because supply chain side you can use it RL. So they in the UPS they are using at the moment into to their processors. So in terms of optimizing inventory, increase the responsiveness, things like that. Then P&G use this to their stock management based on the demand patterns, lead time, managing the stock level. UPS to utilize RL to optimize the delivery routes, and it learned from the real-time traffic data, the package volume, and customer time for window to dynamically adjust the route plan and reduce the fuel consumption and improve the delivery efficiency. So traditional ML or DL, deep learning, cannot do this. That's why RL is dynamically adapting into the environment. So UPS at the moment using this to adapt from the real world traffic data, package volume, and customer time to dynamically adjust our plans, reducing fuel consumption. So they save fuel as well, not just the routing and the efficiency. They even save from their fuel as well to improve the efficiency. The robotic side, of course, is given. So this is from Berkeley, University of California. So foundation for robotics to learn from experience. So they have applied for certain manufacturing and healthcare scenarios into the robotic side. And Siemens try with manipulate object, perform assembly operations, adapting from various object positioning and orientation to improve the efficiency. Then the Harvard researchers try with a large swarm of small robotic called kilobots. These RL agents communicate with each other. So as I mentioned, RL agents can communicate, collaborate with each other. So agent can talk with each other. So that's advanced version of RL. So they can self-organize into desired formation and perform collective tasks. So that's tested with our researchers. So they use the advanced version of the RL techniques to communicate within the agents called kilobots, and they organize themselves, define formation, and perform a collective task. So not just one task, but they collective together to perform multiple tasks. The other tool for RL is the traditional is OpenAI Gym. Now they have changed it to Gym library, so they move away from OpenAI. So OpenAI have a lot of areas to focus at the moment, but OpenAI actually invented or initially started the RL revolution with their Gym library package. But now they have shifted away from the package. Originally, they are the one who founded this version of the RL toolkit, which is originally called as OpenAI Gym. But now they have open sourced this and make it available for everyone. So the gym documentation, so it's going into as you can see, move to gymnasium. It's from now maintained by the Pharma Foundation. So it's moved away from the OpenAI platform, and because OpenAI is now not a non-profit, it's a for-profit organization. So some of the packages, especially most of the open source Python AI packages are open source. So because of that, they have to like little bit move away from some of the open source packages. So this is now moving into this pharma organization. So where you can see we can train certain environments. So here we have certain environments we can test it on. So we have a certain spaces we can set up. So here again, similar to Unity, where we have this environments. We can have 2D environments like this, and then it's try to learn from that. So you can see environment is not advanced like Unity, but still a 2D kind of environment. So it's use Python gaming packages to build on this, and then it's try to learn from this, right? So if you look at the blackjack example, let's try to learn from the blackjack deals and try to learn and adapt on the action space. So like that, we can apply these things within the Python packages, and then we can build our solutions from that. So this is another humanoid. So it's a one similar to what I showed earlier in the Unity one. So we have the similar examples, but the interfaces environment is not advanced like Unity because of the limited capability. But actually, this is the one that released earlier because this is initially released with OpenAI platform many years ago, even before ChatGPT. They were releasing this and they were testing out a lot of research projects on this area. Then only after a couple of years, Unity released this Unity RL agent platform. So now this is moving away from the OpenAI and into the open source pharma organization, but still you can get the core capabilities and libraries and all the things. So this is now moving into the gymnasium documentation, the gymnasium.pharma.org. I will share this link as well. So this is the two main kind of frameworks, standard frameworks out there. But other than that, there are a few other text-based RL frameworks are there. There are altogether like 20, 30 different frameworks we can find. But Unity, ML Agent, and the Gymnasium frameworks are the standard two frameworks at the moment that we can use in our reinforcement learning projects. These are the mainly two type of frameworks that we can use. Other than this, we have some text-based frameworks also that we can apply. Okay. As I mentioned, now I think you have a proper understanding about the RL, how RL works, how we can apply RL within the certain the environment. So you need to have. So I will go back to the first diagram I showed again. So you need to have environment, you need to have the agent, you need to have action, rewards, and observation. And as a tool set, you can use Unity ML agent or Gymnasium framework to set up this. So based on that, we can apply for a lot of use cases. I have shown a lot of scenarios in healthcare, supply chain. We can use gaming, robotics, automation, like a lot of areas we can apply. And we have the advanced version, which is called Deep RL, Deep Reinforcement Learning, as well as in the basic scenario, we have single agent, but we can also have multi-agent. So in the Harvard research I mentioned earlier, they have created a swarm of agents. So they have multiple agents that can talk to each other and they can perform a collective task. So just one agent we mostly discussed and perform one task, but if you collect that with 50, 100 agents, then that can be a collective task that can be created. So those are kind of advanced techniques, and the industry and the technology is moving forward into those areas, which is a more advanced version of RL for the reinforcement learning. And the main thing is to do any of this, we don't need the data. So any of the use cases I have shown you, we don't need any of the data that we discussed earlier. So there's no need for data. Everything is easily set up within the environment. What you need is the environment, and then based on that, we can set up everything, right? So then there are other learning techniques like Q-learning. So these are other other techniques within the RL that we can set up. So Q-learning is again try to do optimize, like try to more optimize, because I mentioned, for example, if it is 1 hour for ML, 3 hour for deep learning, 5 hour for RL. So then we need to find a way to optimize this algorithm to reduce the time to do the train. So then where the techniques like Q-learning comes in, where we have certain optimization techniques that we can apply to improve the efficiency. But that doesn't mean that we can complete the project or training within 1 hour, but it's try to reduce the 5 hour time period as example into a limited time frame. So those are the kind of techniques that we have at the moment, and the industry is moving forward in that. So you can see the reinforcement learning is kind of a unique way of looking at the AI solutions, and we cannot apply this for almost anything. So there's always limited number of scenarios that this can be applied. So if you have any questions, you can ask before we are wrapping up the session for today. You can ask for any questions that you have. So we discussed today to summarize